Hi, my name is Mark, and welcome to Mk1 Mechanics, where I am designing and producing a yo-yo from start to finish. In this episode, I'm going to be going through the initial CAD work for this yo-yo. It is going to be an organic-looking 53 by 44 millimeter yo-yo with profile fit steel rings. So what you can see here is the CAD software I'm using, FreeCAD. There's a link to the version I'm using in the description. It's an experimental branch which has features that I like using. And this is the part of the cross section of Yoyo showing part of the guts and a cross section for the bearing. Over here, you can see the two sketches. These are separate items. Let me pop into the bearing real quick so you can see how this one is set up. This bearing is designed to be kind of like a mock version of a double straight bearing. And you can see it's sort of like a concave bearing, but it has these straight facets. They look cool. I like them. And you can see the general dimensions here. The dimensions in this file are set to use metric. This size C bearing is imperial, so some of these dimensions have a lot of decimal points. They are 3/16 of an inch wide and 1/2 inch outer diameter and 1/4 inch inner diameter. These are radiuses, so those are half that again. So let's go ahead and close this sketch over here and can go ahead and revolve it, and I hop over to the part workbench and hit revolve. This sketch is on a different plane, so let's revolve around the x-axis, and that gives us this nice shape here. All right, that looks nice. All right, and let me switch the view mode. This is without the extra lines. You can see a double straight bearing. I'm missing all the fancy details about the inside of the bearing, but this is mostly for aesthetics and to make sure that the size will work out when I'm looking at the Yoyo sketch. So there we go. And here are the guts. So now let's take a look at those. There's a button right here which will slice the other geometry so you can see the sketch better. Also sometimes just like turn it off to see the sketch better. There we go. So these guts are already dimensioned, and I'm going to leave those alone for now. I talk about them in more detail in one of my earlier videos. But let's get right to drawing a sketch for this yo-yo. So first what I'm going to do is put some lines, some construction lines toggled here. And these construction lines are to help like lay out a sketch. They don't become part of the final drawing that I export. And I'm going to set this position of these to show the outer boundary of this cross section. Now this cross section is only 1/4 of the yo-yo, so it's going to be half of the width and half of the diameter. So 53 divided by 2 yo-yo radius. All right, there we go. And all of our sketch is going to fit within this area. Let me stick that there. Click, click, Shift O. All right. So we don't want anything poking outside of this, so that our yo-yo is actually these dimensions. So this is going to be an organic shape. I'm going to draw kind of like the major arc of the yo-yo here. something like that. And there's a couple things here that are going to be a little bit tricky to make them all connect. So there's going to be a smooth groove over here. And I already know from sort of like testing this ahead of time that this smooth groove is going to need to have some flat sections in the sketch to make it easier for the constraint solver to decide where everything should be placed. The constraint solver is a part of many CAD packages that allows you to add dimensions or other constraints to things, and it will move things around until those constraints are resolved. So I've selected this vertical segment here, kind of hard to see with all these lines, and this arc, and I'm going to hit T, which makes them tangent to each other. Oh, here we go. There we go. Now you can see the two lines a bit better. Yeah, so those are tangent. That means that where they touch, it is a smooth transition. This arc is partially unconstrained. I can move this point or this point around to adjust the size. So I'm going to add another line here connecting to that part of the smooth groove and select those, make them tangent. And you can see when it's solved, even these lines over here moved because that was easier for the solver to figure out. So I'm going to leave this sort of like angular right now because it's easy for the solver to just kind of like shuffle stuff around without things forming into a strange convoluted geometry. All right. So one trick that I've learned is there's a very nice way to sort of like set up the uppermost part of a curve, and that's to put a point on it. You can see it's constrained to be on the arc. Select the center point and then hit V to vertically constrain those two. And now, if you imagine this as part of a circle, this point is always at the very topmost part, even if the arc doesn't go all the way there. So we want that to be here where there's like enough space for it to actually be on the arc. And I don't want this to be too close to the edge because I'll make kind of like a pointy organic. I'm going to constrain it to be about 4 millimeters from the edge, and I'm also going to kind of tie that to this height of 53 millimeters in diameter. All right. Okay. So one thing that I very quickly am realizing I need to constrain here is the diameter of this. I'm going to go ahead and set that to 16. That will keep this arc from moving too much other than like where these endpoints are. So this center point of the arc is fully constrained now, and between that and this radius, this arc is not really going to move other than the endpoints. So let's draw the face of the rim and kind of like get a general shape going here so that we have something to work with. These are going to be tangent, and this is going to need to be rounded off. I'm going to use the Fillet Tool here. Click, 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 click. I'm going to make these equal, and I'm going to make them Shift R, make that have a 1.5 millimeter. Ooh, that was too big. I need to give it more space, 1.5. So that was a case where the solver could not solve it because the radius was too big for what I was trying to do here. So let me set that. There we go. Okay. So now this face of the rim is kind of set there, and this arc turned light green. That means that arc, both points and the arc itself are fully constrained. So none of that can move, which is good. It means our drawing is starting to get stable. And let's connect some stuff here and sort of like sketch out the diffraction style cup that this is going to have. All right, V, 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 horizontal. All right, I'm going to give this a constraint of 5.7. There should be enough space for it, hopefully, so that the axle doesn't poke through. So, quick note down here. The axle is 8 millimeters long on this design. So I've made the hole 4.2. This is on one side of it, so half of the axle will be here, half of it will be over on the other side, and the cups will be 11.4 millimeters apart. That gives them some space between them, including any like angle that's there from drilling the hole out. And we can see here, I added a little reference here. That is how much space there would be between the center of the cup and where the hole is. It's not much. That's fine though. Okay, let's go over here and add a fillet between that arc and this line and set that to 1.5 also. All right, it's something. Let me go ahead and close, and let me turn on lines. Some of the view modes, if you have a view mode with the lines turned off, like V6, you won't be able to see the sketches. V7, you will be able to. So let me go ahead and revolve this. I'm going to hit X and OK. And we have our first 3D version of this. So I have some fun macros that let you kind of check the mass and other details of a yo-yo design as you're working on it. So I'm going to rename these. This is the bearing, oops, bearing revolve, and this is the yo-yo, aluminum 2.81. This macro will calculate based on densities that are written into the label of the yo-yo itself. There's a link to this macro in the description, and you can follow the usual custom macro installation instructions for FreeCAD if you want to use it. So this is a very chunky shape. We can see how thick it is. So this calculation says that the yo-yo would be 93.6 grams. That's obviously way too much, especially because we're going to add a steel ring here, and we want the aluminum part to be pretty light before we add the steel. That'll give us some room to like do some stuff. So let's make this thinner. I've made this fillet on the outer edge 1 millimeter instead of 1.5. Be a little bit more squared off, but that's fine. This shape should be comfortable anyways. And bring this over, and we need to kind of like clean up these shelves so that they work the way they're supposed to and have the right dimensions. So I'm going to add these fillets. These two inner ones are going to be the same. These two outer ones are going to be the same. I believe those are going to be 0.5, and these inner ones are going to be like 0.2. And these shelves are going to be, whoops, I hit Shift V. I need to do Shift H for the horizontal constraint. It's going to be 1 millimeter deep. And the other sort of thing that's going to go on here, this point is going to be 6 millimeters up. That's kind of where the point of the corner is. And as far as I could measure it with my calipers, and I'm going to set an angle here of 106. There we go. So you can see that this fully constrained green section is creeping up. And this, I'm going to name this to shelf height. And I'm going to select these 2 points, Shift H, and hit equals constraints dot shelf height. There we go. And now that has the same constraint. And I'm going to set this line there to be equal. And I'm going to set a vertical constraint here of 11. All right, and that matches the drawing I had from earlier, where the inner one had a diameter of 12 and the outer one had a diameter of 22. And that is our official cup from the diffraction. So I'm going to make this, I'm going to bring the schmoove in like there. So one of the things I want to be able to control with the constraint is how much space there is in here. Here, let me pop out real quick. Okay. And let me mirror this over the YZ plane. There. Nope, I mirrored the wrong thing. I'm gonna mirror the Yoyo. Okay. Here we go. YZ plane. Okay. All right. So there's this spot between these two main arcs, which is where the string needs to get down there, right? And when you're playing, there's this angle between all of the parts, and we want that angle to kind of like, it's like, if you can see this line here, like this is kind of where the string can be without making a lot of contact with the body of the yo-yo. We want that to be reasonably big, so I want to constrain this point to be far away from the center line of the yo-yo. So I've set that to 4 millimeters. And if we adjust some of these other parts, so we can see how the solver is able to adjust that to change. Like if we move this apex a little bit to the right, then this goes down farther. If I make this bigger, this whole section needs to be up farther because this arc is locked in place with the other constraints. All right, one of the other things I do need to constrain here real quick is this schmoove. It needs to be a certain distance from that section in the cup. So let me fillet it real quick so that I can constrain the correct points. Click E to make those equal. Let's do 1 millimeter. All right. And let's click here and here. So when constraining between a point and a line, you want to do Shift D. It'll follow the direction that's closest from the point to the line, that's perpendicular to the line. So this is going to be 7075, so I'm going to set this to like 2.3 millimeters. I don't want to get too gutsy there. And then there's a couple other things that are unconstrained here that I can play with for like aesthetic reasons. I can make that bigger. For example, I can move this up and down. I could adjust the radius of these arcs. I can make this line bigger or smaller, and so on. I'm going to leave most of that alone now. Because it's functional and it has most of what we need. So this arc is going to blend this big arc into the flat part of the cup. I'm going to try to give it as big of a radius as I can that doesn't just like destroy everything. Okay. 2 is too big. I'll set it to 1 for now. Okay. It doesn't like it. Something else broke. It somehow got put on the wrong arc. Here we go. I didn't think that should be too hard. I think I had something odd selected. All right. So that is a thing. I'm going to go ahead and constrain this line here. I hit the wrong key. Shift D. Let's do 0.6. Make it a short, flat little section. That may need to get adjusted later. And then I'm going to move this line over until this starts to get thin. So the steel ring is going to be up here, so I'm free to remove stuff from over here until it starts looking good in terms of being efficient. I'm going to add a construction line here to see how much distance there is between it, and I'm going to make these perpendicular with the N hotkey. And then I'm going to constrain this to 1.5. Okay. So that kind of sets our minimum thickness there. I'm going to go as pretty much like as small as I can go. But not too small. Okay. Oh, I'm guessing I will need to revisit that for aesthetics as well. Let's go ahead and close and look at this and see how we're doing. That looks pretty nice. I think that fillet there could be bigger. Doesn't look great when it's that abrupt of a transition, I think. Unless it matches those, I guess. I don't know. And the calculation is saying that the body is now 51 grams, which means when we add the steel rings, there will be plenty of room to do that. So let's just do one more thing real quick and give these an appearance. Control D, set this to aluminum. I'm going to pick a sort of light blue there, and then pick this part, aluminum, light blue. I pick this, set it to the steel is just kind of like a black, which is kind of odd, but that must be like some CAD convention or whatever. So here we go. This looks nice. Pleasant. It'll be very light without the steel rings. Let me go ahead and tune up that little bit there to be a bigger radius again. All right, that's probably going to look a lot better. Yeah, there we go. Cool. Still noticeable transition because the part after it is flat, but that's kind of like hard to stop it from looking like a transition when it goes from one angle to another like that. All right, let me throw this into perspective mode real quick so you can kind of see it from a better camera, or a different camera, not necessarily better. Then back to orthographic. Here you go. And here it is in see-through mode. You can kind of like see the shape through there. I think that looks pretty good. All right. So the next task is to add the steel rings, which is a little bit of a challenge. Some CAD packages have a way to drive multiple separate bodies out of a single sketch, where that has separate, like, fully encircled areas in it. FreeCAD does not do that, but it has some other tricks up its sleeve to allow you to do that pretty easily while still sharing like general shapes and dimensions and so on. And we will talk about that next time. Thank you.